Hello, everyone. Welcome back to more Turing Machine. A glutton for punishment. I enjoyed the last game with extreme mode where there's two. This one's not lined up properly. There's a snap point here somewhere, isn't there? Maybe only on some of them? This one had a snap point. This one doesn't? Weird. Anyway, yeah, the rest of them all do. I set up another extreme mode, and this time we're still using 5 verifiers. But I checked hard instead of standard, so we should have some cards from among the hard cards. Weirdly, I think this... No. This is the only one we got. I think all the rest turned out to be from the easy or standard set. Yeah. The rest of these all are mutually exclusive, so, and they're all relatively simple, so I don't know, this might not be so bad. If you want to play along before I get started, you know, the code's here, but also it should be in the video description for you to copy. Go have fun and unpause the video when you're ready to watch, because I'm about to start. Here we go. I mean, there's a number of things. Oh, I didn't draw in the lines. You know, let me just, you don't have to watch this. I'll draw in lines on this thing and you guys can, I'll do that off camera. Okay, I'm back. I drew in this horrendous grid on my note sheet so I can keep track of what possibilities I've already ruled out. And there are quite a few that can be easily ruled out here. Well, there's at least a couple. There can't be 3 3s. Or 3 1s, or 3 4s. So the bottom right of B, C, and D can all be dismissed. That's just never allowed because it would make all the other verifiers redundant if any one of those things were true. Well, not if any one of them were true, but if they were the ones being verified. Maybe, by coincidence, there could be 3 4s. But if so, this card wouldn't be telling, or this card wouldn't be telling us that. Rather, this would be telling us that the sum is greater than 6. The thing about an ascending sequence seems important. Right? Could there be really 3 numbers in ascending order? It seems difficult for that not to give us some kind of problem. There would definitely be no pairs, so this card couldn't be telling us anything. And this card could tell us something. It would tell us either that blue is the smallest or blue is the largest. And that would mean this card couldn't tell us anything. Well, no, if blue were the largest, yeah. Then telling us that purple is the smallest still wouldn't be new information. So, yeah, I think this is impossible. There can't be a sequence of 3 ascending numbers, because if there were, this card couldn't tell us anything, and all this could do is tell us which end of the sequence is, which way the sequence goes. This would also only tell us which way the sequence goes, so this card couldn't say anything. And this card, we know, would tell us there's exactly 1 3, because any sequence of 3 ascending or descending numbers must cross through 3, and obviously can't do so twice. So, we know that there are not 3 numbers in ascending order. That's the top left of E. Ascending or descending. E is this one. Okay, I'm pleased with that little inference. Or, I guess it's a deduction, right? Inference is generalizing? Sort of? Or, I don't know, maybe this is an inference. I don't quite understand the difference between inference and deduction. I think this is a deduction, and I don't think it's an inference, but I don't really know what that means. What else? Well, if there were two of any of these numbers, 1, 3, or 4, that seems like it would be interesting, right? Because it would tell us there's a pair, and so this card couldn't do anything. And this card would tell us which one isn't part of the pair, either telling us it's the largest or smallest. So if we had two of any of these numbers, we could pin down exactly which two numbers are that, and which number is not part of the pair. Right? It wouldn't tell us what that other number is, but we could tell which one isn't part of the pair. And that would mean this card couldn't tell us anything, right? So that doesn't let us rule out 2 3s, because then this verifier would still be telling us something. It would tell us, oh, there's 2 3s, and uniquely there's, whatever. But it does tell us there couldn't be 2 1s or 2 4s as the verification constraint. Now, if there are 2 3s, is that impossible for some other reason? Yes. Because it would also tell us there... Well, hang on. Maybe not. If there were 2 3s, would this be redundant? It couldn't tell us that blue is 3. It would have to be telling us blue is less than 3 or greater than 3. Ah. Right, and then this wouldn't be telling us anything interesting. Because blue would have to be the odd one out, and then this would point to blue and tell us either it's less than or greater than 3. Which is what the other two numbers would have to be. Could this tell us that blue is 3? Hang on, maybe it could. If there were 2 3s, and blue were one of them, this would have to tell us which number isn't a 3. And then we would already know that blue is 3. So, right. B and A would make one of... If we had this tell us there are 3s, then one of A or C would rule out the other, either way. So if there are multiple 3s, if there are 2 3s, one of A or C is redundant. And if there are multiple 1s or 4s, then one of A or B is redundant. I think. No, hang on. Wait. Because if there are... Shoot. If there are multiple 3s, C could be telling us how many 1s there are. Couldn't it? Well, but what would D be telling us? It couldn't tell us anything about the sum with regard to 6, because we would know that's above 6. So it would have to be telling us how many 4s there are. But I guess these both could be saying, oh, there's no 1s, there's no 4s. Neither of those are really redundant. Right? This is still pointing out which number is different from the 3s. Telling us whether it's a 2 or a 5, I guess. And then these, I guess one of these could tell us something, couldn't it? It couldn't tell us yellow is equal to purple, because that's obvious. It would have to be part of the pair, and we already know the pair's distinctness. Well, it couldn't actually even... It couldn't tell us whether yellow is greater than or less than purple either, because this would be... Or no, hang on. Right. If there's 2 of a number, in this case we're looking at 3s, then this card can't be giving us information. This is. It's telling us which number is the odd one out. So this can't be comparing any 2 numbers in that case. We'd have something telling us how many 1s there are, telling us how many 4s there are, and then we'd have this. But that's actually useful. Because it could be telling us, oh, there's 2 numbers in ascending order. That means there's 3s in a 2, not 3s in a 5, right? Or vice versa. So I think if there are 2 3s, there is actually a way that all the rest of the verifiers could be useful. So I don't think I can rule this out, although I hoped I could. I haven't actually already done that, have I? No. Okay. And if there were 2 C's? Well, we know this would be telling us which number is... Sorry, if there were 2 1s told to us by C. This would be telling us which number isn't a 1. This couldn't possibly say anything, because there is no unique smallest number when there's 2 1s. This would have to tell us whether there's 0 or 1 3s, and it couldn't tell us 1, because then we would already have a unique solution, knowing which ones are 1s and which ones are 3. So it would have to tell us there's 0 3s. Likewise here, it would have to tell us there are 0 4s. So we'd have 2 1s and either a 2 or a 5. And we would have this information, right? Whether the sum is equal, less than, or greater than 6. If it were less than 6, then the other number would have to be 2. And then I wouldn't need this verifier to get the code. So that can't be the case. If we're saying equal to 6, the other number would have to be 4, which is impossible. No, hang on. Why did I think I needed to know from this how many 4s there are in this world? I don't, right? I do. No, I don't know how many 4s there are. Okay, what am I talking about? Okay, try again. I would know there are 0 3s, because this would have to be bottom half. This would not be meaningful, given that this one already exists. Also, this would be impossible. But which of these criteria could I get? If it told me there was 1 4, that would be redundancy, so that's impossible. But it either tells me there are 0 4s or the sum related to 6. Less than 6, I would have a 1, a 1, and a 2 as the only option. So that can't be. Equal 6, I would have a 1, a 1, and a 4 as the only option. So this would be redundant. So it would either have to tell me there are no 4s or that their sum is greater than 6. But if their sum is greater than 6, then it would have to be 1, 1, 5. And again, this would be redundant. So if there are 2 1s, this would have to tell me there are no 4s and there are no 3s. And it would pinpoint for me which one is the 2 or the 5. However, again, this card could provide that clarity. It could tell me whether the other card is a 2 or the other number is a 2 or a 5. So I don't think I can rule out 2 1s either. What about 2 4s? I assume that's important somehow. Two 4s, again, I would know which ones are the 4s because of this card. Anytime there's a pair, we can ignore this, and this card tells us exactly which 2 numbers are parts of the pair, and whether the other number is bigger or smaller. Oh, hang on. Doesn't that mean that the 3's universe was actually impossible because I'd know which is bigger? If there were 2 3's, I'd know which number is not a 3 and whether it's bigger or smaller. So this couldn't tell me anything. This would have to tell me there are no 1s. This couldn't tell me anything. This would have to tell me there are no 4s. So I'd have 2 3's. The other number is either 2 or 5, and I know if it's bigger or smaller than 3. So this would be redundant. Okay, finally, I knew that something was messed up here if there were 2 3's, but I didn't see it. The same logic does not apply here, because everything's bigger than 1. If there were 2 4's, I think I was saying, I forget if I finished this or... If there were 2 4's, I would know which 2 they are and whether the other one's bigger or smaller. So this would have to be telling me no 3's. And this couldn't tell me anything, right? Because it couldn't tell me blue is 3. And if it told me blue is greater than 3 or less than 3, I would already know that. Because it can't be... Either it's identifying a 4 I already know about, or it's telling me the same thing as A. So if there are 2 4's, there are no 3's and no 1's. Okay, that's interesting. This wouldn't tell me anything. Would this? I think so. Because you can use the sequenceness to disambiguate between a 2 and a 5. Only one of those is next to 4. No, hang on. Am I dumb? It tells me, right. It tells me there's no 1's, there's no 3's. There's only the 2 4's and either a 2 or 5. And I know whether it's the other number's uniquely biggest or uniquely smallest. So there can't be 2 4's either. I mean, again, the code could contain 2 4's, just this verifier can't be checking for that, is all. Okay, I knew we could make progress on this, but it's a lot harder when there's so many possibilities to rule out. Kind of annoyed I haven't been able to figure out anything about A. Because it's the most problematic one with 8 possibilities. The others are down to like 5 or 6. If there were a pair, yeah, I mean, that doesn't seem easy to disprove. And if I could uniquely tell what's smallest or... Well, if I could tell what's smallest, that would make this half of B redundant, but this half would still be telling me whether there's 0 or 1, right? And I don't see how I could prove that there's redundancy there. Does this help somehow? Not really. What about, okay, does it already test 3 numbers in ascending order is impossible? Yes. I don't remember how, but I proved it. I believe myself. What about no numbers in order? Oh, wait a minute. This is checking specifically ascending. I've been seeing... Okay, hang on. Oh, no. I was thinking this is the one that's like a sequence of strictly increasing or decreasing numbers. This says sequence of ascending. Okay, so it's... This is the medium version of that hard card, I guess. But it still would have... They would have to be in sequence, in order. Like, contiguous. And so they would still have to include a 3, and that was all I needed for this to... Okay, got it. So I haven't failed. I'm not going back on my proof that this is wrong, is what I'm saying. But could there be no numbers in ascending order? I mean, sure, there's lots of ways that could happen. I think. Yeah, because it doesn't affect any comparisons of anything to anything. You know, even though none of the numbers are ascending, yellow could still be bigger than purple, or smaller than purple, because it could be smaller by more than 1. Alright, I guess this is as much deducing as I would like to do before I start asking questions. I feel like I hit the low-hanging fruit for my skill level. Well, I mean, I hit the high-hanging fruit for my skill level, I feel like, but... Okay. So I'm going to have to be hitting up A pretty regularly, I would think. So let's try to choose distinct numbers. And, I mean, I don't know why. I want to assume A is the bottom half here. If it were the top half, that would be pretty cool. But, I don't know. For some reason, it seems less likely, but I don't actually know how the verifiers are chosen. Does it, like... I don't know. So I don't know enough about the selection process for these to know what the probabilities are, so who knows. But if it's checking for no pairs, I don't know. That's going to give me less information. Maybe? I want more information? Maybe? I think I'd like to lean on A, B, and C. A and C have the most possibilities, and B has the most interaction with A, so I could maybe narrow them down well together. But maybe that means I should leave A... Oh, I don't want to leave A alone. But... if I left... If I solved A and found it was the bottom half and that it was checking the smallest of something, that would get me most of the way to solving B. I could completely ignore the top half of B. So maybe that won't happen, but maybe it will, and so maybe that's a good reason to leave B alone for a bit. I have other promising 5s to investigate. I don't have to go for B. So maybe A, C, and E? Sure. Also, if I find that A is comparing purple, either biggest or smallest, I'll make a lot of progress on E. So, I don't know, that seems cool. Let's make sure I have a unique largest and smallest item, which means they have to all be distinct. That puts me targeting A pretty well. And for C, well, no, I don't want blue to be 3, I think. So here I'm testing sort of the 0, 1s, and which I think is most likely to be yes, and blue greater than 3, which I think is as likely as not to be true. And then for E, this does have a sequence in ascending order. And there's a meaningful result down here. So I think 4, 2, 3 is as good a question as I can ask, given the goals I have anyway. Maybe I have the wrong goals. Can't disprove that. So let's talk to A. It says no. So what does that mean? Either A doesn't want there to be a pair, or rather, either A wants there to be a pair, which would be quite informative, or, well, okay. It can't be the case that A wants there to be no pairs. It can't be the case that A wants yellow smallest or blue biggest. That's these two quadrants. They're not quadrants, I know. So that's what I'm learning from A. I still think I want to talk to C. Another X. So it can't be checking that blue is greater than 4, which is the rightmost on the top of C. And it can't be checking that there are no 1s, which is the left of the bottom of C. It's a little annoying that I wasn't able to rule out 2 1s like I could 2 of all the other digits, but I just don't think that would make something redundant yet. But if E says no, I believe that would eliminate 2 1s from the possibility scape, right? Because then this was the one piece of information that was helping me disambiguate the 1s. If we know this isn't what this verifier is checking, then we can go back and say there aren't 2 1s, it would be ambiguous. So let's check E. It says no. Okay, so I want to double check this, but I think I can also conclude there aren't 2 1s. So no, there's not a sequence of length 1 in ascending order. That's the middle of the top of E. Or rather, it's not verifying that that's the case. And furthermore, it's not verifying that yellow is less than purple, which is the bottom of the left. Oh, and I have to put an X here. Okay, so let's go back now and ask, is it still possible for there to be 2 1s? I think no. So let's go through that whole logic again, but knowing that this can't be saying there are 2 numbers in ascending order. Oh, shoot. But the same thing is, if it told me there are no numbers in ascending order, that would also narrow it down, because it would prove it couldn't be 1, 1, 2. It would prove it would have to be 1, 1, 5. So, okay, never mind. I don't think I've proven that there can't be two ones. Or I don't think I can prove it. I definitely haven't proven it. Okay. I don't think we're ready to submit an answer, so time to prepare a new question. Well, I mean, I guess we could do more deductions. I don't think there's a lot going on. That would warrant any deducing. Yeah. I'd like to check in with the ones that, I mean, A and the two I didn't talk to yet, right? Because they're the ones with the most possibilities. A, B, and D. It would be nice if I could leave B alone for a long time, but I might not get lucky on that. Now, the annoying thing is it's going to be rather tricky to rule out A effectively. Because in order to rule out the top right of A, I need to submit a pair. But that means I can only be in one of these categories on the bottom, which would leave me with 3 left, which is pretty bad. So I think I want to try aiming at the bottom of A until I run out of ways to do so, basically. Which means not submitting any pairs. A, B, and D. Okay. So let's try like yellow largest, purple smallest. Like that, maybe. That's a good aim at A. How about B? This is also aiming at purple smallest here, which is a little annoying, but there's not much I can do about that. Anytime I aim at 2 different things on A, I'm going to be aiming at something here. I mean, I guess that's fine. And I'd be aiming at 0 3s, which seems fine. How about D? This would be aiming at a large sum and 1 4. I think that's all fine. I don't have any reason to want to ask some other question that I can think of. So let's try 451. A. It says no. So, what does that mean? 451. We can't be checking that yellow's biggest or purple is smallest. So here and here are impossible now. We still could be looking for pairs, though. I wanted to ask B and D, right? Weirdly, B and C are equally vast, but I hope I'll find some way to disprove that there are 2 ones. So I'm going to talk to B first, I guess. Well, I mean, no, let's talk to D. Because I still sort of wish I could figure out what's going... Well... What are the 2 possibilities left for A, comparison-wise? Blue smallest or purple biggest? I mean, those all seem possible. I could still ask which one's the smallest. Sure. Another X from B. 451. So we can't be testing that purple is the smallest. And we can't be testing that there are no 3s. Okay. And we still need a lot of clarification from D. A check. Ooh, that's exciting. I've forgotten what it feels like. What does that mean? Either there's a large sum or there's 1 4. That's cool, I guess. Of course, both things could be true. There could be a large sum and a 4. But just this verifier can only be testing one of those two, as usual. Probably there is a large sum. But that may or may not be something the verifier is telling us. All right, any new obsolescence or redundancy or superfluosity tests we could do? I still want to figure out if could it be that there are 2 1s? Still seems hard. But we'd know which one is the non-1. This would have to tell us there are 0 3s. Is that still possible? It's not. Because we gave it a code with... Oh, I must have... Yeah. This round, I gave this 0 3s, and I said, how do you like them apples? And it said, no, I don't like them. So, before, when we tested 2 1s, we said, okay, this is going to tell us which one's the largest. And that means this couldn't tell us anything. So it would have to be this card telling us something. And the only thing it could tell us would be 0 3s, because if it told us there was 1 3, we would know the code uniquely. But now, finally, we know this can't tell us 0 3s, which means this can't tell us 2 1s. Finally. Okay, I'm ready to pop open a bottle of champagne and celebrate. That's an exciting outcome. What did I find out about sequences? Something, surely. It can't be telling me that there's a sequence in ascending order of any length. It may or may not be telling me there's no sequence. Interesting. Funnily enough, telling me yellow is less than purple is a way to say there is a sequence, kind of, right? But that would be okay, because this one wouldn't be telling me there's no sequence. Huh. So what are the comparison possibilities left from A? We have top left and bottom right, if we're looking at this card. So it may tell us blue is the smallest, or it may tell us purple is the largest. I really hate this system for taking notes, but if I do it any other way, I get confused about what I'm note-taking. So B can't be telling us that purple is the smallest. Is that interesting with A somehow? It sort of is. Not? Yeah, because A is either telling us purple is the largest or blue is the smallest. So these two could peacefully coexist. I think I can now conclude that the code does sum to more than 6, right? The problem is I can't conclude that's what this verifier is telling me yet. It might tell me about 4s. But remember, it's either telling me the sum is greater than 6 or it's telling me there's a 4. And if there's a 4, in order to not be more than 6, there would have to be 2 1s. Which means the bottom of A couldn't tell me anything. The top of A would have to tell me there's a pair. But that would be... well, no, it wouldn't be redundant from telling me there's 2 1s. B couldn't tell me anything. Ah. Yes. Wait, yeah. B, the top of B couldn't tell me anything because there'd be 2 1s. The bottom of B couldn't tell me anything because there'd be 0 3s. But this doesn't let me rule anything out as redundant. All it does is let me conclude, yeah, the code is definitely more than 6 in total. It doesn't tell me this has to tell me that, because I can conclude it from whichever one of these is true. Blech. This is just a reminder, I guess, that your goal is not to figure out what the code is. You almost never get information leading you directly to the code. What you get is information telling you what the verifiers are saying. And then when you finally know what all of them are, you use that to give you the code. So trying to deduce what's true about the code is just like the wrong idea most of the time, right? I think. So how are we doing here? We have 1, 2, 3, 4 verifiers with 3 slots in them. And then this one with 2. I'd still like to aim at the bottom of A. And, I don't know, at 2 of the other 3s? Let's try to leave B alone. A, C, and E again, same as round 1. So, to aim at A, I need to make sure that, let's say, blue is the smallest, but purple isn't the largest, uniquely. Okay. So let's do blue small, yellow big. 152 is an example of the shape I want for A. I could also do 155, by the way. Instead of putting me just in this category, that puts me in this category and this category. Either testing blue is small or there's a pair. It's sort of equivalent, I think. Like, when you're aiming at 3, something that has 3 possibilities, eliminating one of them, or aiming for one of them, is the same as aiming at 2 of them. Because one of the answers lets you eliminate the one you're aiming at, and the other answer lets you eliminate the other 2. So I don't think it matters. It makes a huge difference whether I include a pair in this or not, as long as I just make sure purple is not uniquely largest. So for C, well, I can't aim at 2 of these, huh? Let's see. And I can't really aim at blue bigger than 3 at all. Well, I mean, okay, I could test 3, 5, 4. In this way, blue is still smallest, purple is still not biggest, but now I'm aiming at this. And the 0 1s. No, not the 0 1s. Yeah, well, I'm aiming just at this, which means I'm also aiming at these 2. But I think this is likely to say no, so maybe this is not the best. What if I did 4, 5, 5? Blue is the smallest. but it's still bigger than 3. So I'm aiming at sort of the most likely part of this combined card. How does that do on E? Does this make me happy? What do I know about E? It might say there's no numbers in order, which we're not aiming at right now. Might it say that yellow equals purple? It might. Okay, I think this is fine. We're aiming at 1 or 2 slots in each of A, C, and D, which is all I can really ask for. So let's put down this as our question. And ask A. It says no. So it doesn't... Oh, this is great, actually. Because it's not checking for blue being smallest, and it's not checking for a pair. Which means it must be checking purple largest. So purple can't be 1, and these can't be 5. Great. Does that revise my decisions of what I want to ask of these other verifiers? Maybe it should. Purple's the largest. There might or might not be a pair. Purple is the largest. Well, that means this can't be checking that orange is greater than purple, right? That's just not possible. Not orange, I usually call that yellow. Okay, which means if I ask E... Oh, shoot. No, this is fine. I'm aiming at this part of E and not this part of E. So when I ask E, if I ask E this round, I will get exactly what it verifies solved. I might choose not to ask E anymore now that I got a little extra information out of A than I was expecting. So do I want to ask C whether blue is greater than 3? Or is that suddenly bad? I think that might be impossible. Because if blue is greater than 3, then it's exactly 4, right? We can tell that. And then D couldn't be telling us how many 4s there are, because that would be redundant. So it would have to be telling us about the sum. With relation to 6. But if there's a 4, it's very difficult for the sum to be anything but more than 6. Could it be 6? I think it's very hard, right? Because either there's a 3... No, this could be telling us 0 3s. We would need there to be 2 1s. But we would need to somehow not be able to deduce this with other... Like, could this be telling me the sum is 6? It seems impossible. I would know... Which of the cards am I looking at that would currently let me tell... So, like, A, I'm including in my analysis, so I can't make A redundant. A is telling me blue is... No, purple is the largest, right? Yeah. In order for the universe to be consistent, there couldn't be a unique smallest number if this were telling me the sum is 6. Hang on. Am I ruling out? Okay. It can't tell me the sum is 6. I've already ruled that out. But I guess, right, what I'm trying to see is... if all this is telling me is the sum is greater than 6, isn't it itself redundant? And I'm trying to eliminate this possibility so that I can just know that we're looking at the bottom of D and that it's telling me there's a 4. Wait, but then it would be redundant too. Wait a minute. Yeah, I guess what I'm saying is if this were greater than 4, then if this said greater than 3, the bottom of D would definitely be redundant, wouldn't it? And so we would need the top of D. And if this were redundant also, then we could rule out that that's what this card is saying to begin with. So I need to, using what? Cards A, B, C, and E, disprove, or prove that I can tell the sum is at least 7. So if this is telling us blue is 4, and this says that, what does it say again? Purple is the biggest. Oh my god, no, that's impossible. What am I saying? Purple is the biggest? Well, if blue is 4, purple would be 5, and then this would be crazy. We could never be told this. It would be obviously true. So I think this can't be what C is telling us. Let me just double check this. Because using this and this, anything D could tell me, I would already know. Yes. C can't be telling me that blue is greater than 3. Wait, I already have that ruled out. God, I hate these fucking notes, man. Oh, no. Okay, so asking C is useless. I don't know why I thought asking C this question would be good. That's what I already had ruled out. Hopefully I have good questions to ask the other verifiers. I mean, I can't be too mad. I learned a lot from A. Okay, so I spent a bunch of work trying to prove shit I already know. That's cool. What about B? Do I get a good answer from B on this? It already can't be telling me purple is the smallest, but it could be telling me blue is the smallest. So yeah, this is as good a question as any that I can ask B. Let's do that. It says no. What does that mean? It's either... well, it's not looking for blue smallest. Okay. And I guess I need to talk to D or E next. I still think I kind of know that D is just going to be telling me some... I'll figure D out somehow. I want to talk to E, I think. E is another X. Which... I should have checked that I'm not just giving myself information I already have. I had constructed this to be good for E, but I should have double-checked before I pressed the button. So... I got an X for 455. Which means it's not checking that yellow and purple are equal. Okay. As planned, this did uniquely solve E. So what I am being told is no ascending sequence. I wish they had used increasing for this, because increasing has this slight implication of being contiguous, and they've already used ascending order on a different card to just mean, yeah, they get bigger. A sequence of ascending, meaning like they're like one bigger than the previous one, uses like all the same words, but to mean a slightly different thing by introducing sequence. And I don't know, I don't like sequence. Anyway. So that's round 3. There's still quite a lot left, sadly. But I know so much that maybe I could rule out a few more things before I start asking more questions. I still haven't ruled out that it's telling me there's a 3, or telling me there's a 1, or telling me there's a 4. Those are all still possible, annoyingly. The most likely outcome for C is that it's less than 3. I say this just because, like, there's only one way for it to be 3 or one way for it to be greater than 3, since I've already eliminated 5. This is not a very rigorous argument. There may, maybe already there's enough information to know that C is either 3 or 4 from all the other clues. So, like, this is... I would get thrown out of a probability class for that claim, but as a human being, it just sort of looks right, which is not to say that it is right. So anything that targets any part of B is fine, and likewise any part of C, and likewise any part of D. So I just have to find... Well, okay, right. But before I target something, I want to see, can I disprove something? Is there some reason that knowing there's a 3 would make something redundant at this stage? I don't think so. Is there some way that knowing yellow is the smallest would disprove something? Well, I already know purple is the largest. That would be kind of exciting, wouldn't it? If I knew yellow were the smallest. Because I would know that it went middle, low, high. But I don't think that really proves anything. If I knew C were less than 2... less than 3, less than or equal to 2. I don't know. It doesn't tell me much. Okay. I don't see anything I can obviously do here. All I can do is compose a question that gets me some information from all 3 of these, and then ask questions one at a time, stopping each time to see if I've solved the puzzle. I could do the case-by-case analysis of 2 times 2 times 3. Look at all 12 cases. Seems horrible, and I would hate it and want to die, so I'm not going to do that. See if any of them are impossible. You could do just like, I don't know, 7 steps in a way, like, which is what I was just trying to do, is, if I knew what B were telling me, would anything become impossible? It doesn't seem like it would. What about D? If I knew what D were telling me, like if it said there was a 4, or if it said the sum was greater than 6, like, that doesn't seem likely to make any problems. So, okay. So for B, I want to make sure that I don't include any ones, and I make orange the smallest. So let's do that. For C, I can aim at 1 or 2 of these, so let's leave that for a moment. D is the one I have to split the difference on. Split the goalposts. I have to aim... Oh, I mean, this works, right? No, this is bad. This aims at both halves of D. It's actually kind of hard. Why did I decide I want this to be a 4? I don't care if it's a 4, right? I just want yellow to be the smallest for B? Yeah. So I can make blue a 3 instead. And now I'm aiming at the top of D, but not the bottom of D, which is perfect. Now what about C? Is this a good query we like for C? Is it aiming at 1 or 2 of its bits? It's not aiming at the bottom of C. It is aiming at C, blue being 3. Which is about as good as I can do, I think. Although I'd rather aim for blue less than 3. So maybe 2... But this now breaks the question I was trying to ask of B. So I'd have to make this a 1. But that, I think, breaks what I was trying to ask D, doesn't it? No. It breaks what I wanted to ask C? Well, let's see. For D, I'm aiming at no 4s. I'm not aiming at 1 4, but I am aiming at a big sum, so that's fine. For C, I'm aiming at a 1, and C being small, blue being small. So that's fine. This is a workable query, I think. Let's ask C first, because it's possible. That's the only way I could possibly eliminate 2 possibilities at once. 2 on 5. Sadly, it says yes, which is bad, because we were aiming at 2 possibilities this time. So there could be it could be saying there's a 1. It could be saying that blue is less than 3. It can't be saying that blue is 3. So, I mean, we get that. Okay. So we have remaining B and D to ask. I don't know. Let's ask B first. It says no. So what does that mean? It can't be checking that yellow is the smallest. Which means it is checking this. There is a, what, a 1? A 3? A 3, I think. There is a 3. Okay, that's interesting. So knowing there's a 3, and purple is the biggest, and there's no ascending sequence, does that let me rule either of these out as not giving me a unique solution or as being superfluous somehow? Before I move on to asking who's left. D? Yeah. So there's a 3. Purple is uniquely largest. If D were telling me there's a 4, what would it be? I don't know. Oh, shit. I crossed out the wrong... No, I didn't. I thought I had crossed out the wrong thing for B. And okay. I know B is telling me there's a 3. That's correct. Wait. No, it's not. How did I find that out? I asked B and it gave me an X, and then I said, oh, there must be 1 3? What the hell is wrong with me? Oh, no, that's right. No, that can't be. Because it would have given me a check. Hang on. Something's wrong. Did I... Okay, B gave me... I have already verified B with 2 1 3, right? Yes. So let's look again. It was an X. So... I remember it was yellow smallest. Oh, shoot. I didn't ask B anything. No, I did. Wait, but this is impossible. I gave it yellow smallest and then crossed that out, and I concluded it has to be telling me there's a 3. But it gave me an X. Oh, right. It gave me an X when I gave it no 3s, so it's expecting a 3. Whew, I don't know what's going on with my head. Okay, this is all still fine. I'm starting to crack. I'm fraying around the edges, man. Okay. So if C told me there's a 1, would that help? What would that mean? I know there's a 1 and a 3. And I know purple is the biggest. I don't know what C is telling me. It could be telling me blue is big. That's impossible, right? Yes. If there's a 1... via B. No, shoot. Via... Oh, I'm so... There's a 3. I think I was using bottom of C to rule out top of C, which doesn't make any sense. There's definitely a 3. If I learn there's a 1 as well... Can I somehow... Can that be problematic? I don't think it would make anything redundant yet. Because knowing... Well... I guess the problem is it might just not lead to a unique solution. Like, what would... If I assume that C is telling me there's a 1, what would D be telling me? If it told me there's a 4, I would know the code is 314 in some order. I'd know that purple is the 4 because of A. And because of E, there's no ascending sequence. I would know we couldn't have 134, we'd have to have 314. But that is using all 5 verifiers to arrive at exactly 1 unique code. So that seems like a possibility. C could tell me there's a 1 and D could tell me there's a 4. And everybody would be happy. We would solve the puzzle. So that's something to keep in mind, but it doesn't mean that is the solution, just it could be a solution. We're trying to find things that could not be the solution so we can rule them out. What if C told me there were a 1 and D didn't tell me there's a 4? Instead it told me the sum is large. Well, I know there's a 1 and a 3. And the other number has to be at least 3 to make the sum be big. In fact, it would have to be at least 4 to satisfy the constraint that purple is the unique largest. So we'd have a 1 and a 3, and purple would be 4 or 5. And there's no ascending sequence. I think that's not enough information, right? 314, 315, and 135 are all possible in that universe. So if C tells me there's a 1, then it must be the case that D tells me there's a 4. So we've ruled out one possibility in our matrix of 4. It can't be that this says there's a 1 and that says there's a big sum. That's impossible. What about this? Could it tell me that blue... What's left that C could say? Blue is less than 3? Could that lead to a unique solution? If there's a 3 and blue is less than 3... and purple is uniquely largest, then this couldn't be telling me there's a 4, because 3 would have to be yellow, and the 4 would have to be purple, and this would be, so okay. If this tells me that blue is less than 3, then this has to tell me there's a large sum. So if blue is less than 3, and there's also a 3, and purple is the largest, and we have a large sum, like, I don't think there's any problem with purple being 5. And then yellow would have to be 3 again. If yellow were 3, yellow would have to be 3. Because we're saying we know there is a 3, and we're saying it's not... It's not blue, because blue's too small. Could purple be the 3 somehow? If blue were less than 3... purple could be 3. But then there's not really a way we could make the sum big enough, right? Without making an ascending sequence? Purple were 3, blue were less than 3. Yellow would also have to be less than 3, of course. And to avoid an ascending sequence, we couldn't have... Well, also, I mean, we would need them both to be 2, right? To get the sum high enough. And then we'd have an ascending sequence where yellow is 2 and purple is 3. So... if this tells me blue is less than 3, then yellow has to be the... well, and this tells me there's a large sum, right? Well, wait a minute. If this is telling me blue is less than 3, and this tells me there's a large sum, well, can it tell me, can it not? Can it instead tell me there's a 4? Is that possible? Blue's less than 3, but there is a 3, and there's a 4. That's not possible. Because the 3 would have to be yellow, the 4 would have to be purple, they'd be ascending. So if blue is less than 3, I have to be told there's a large sum. And there's still a 3 somewhere, which has to be yellow. To avoid a sequence, purple would have to be 5. And blue would have to be 1, right? So I think if this tells me there's a 1, there's a unique solution. If this tells me purple is small, there's a unique solution. So I don't need to ask D anything. Can I ask C something? Have I already done that? I have. Ugh. I think I have to wait till next round then. But before I commit to that, I really want to make sure. Yeah, is it possible the two solutions are the same? Could I just enter the code that way? Because if I learn there's a 1, then doesn't it have to tell me there's a 4 as my recollection? No, maybe it doesn't. If there's a 1, there's a 3, and there's a 4. Purple is the largest, so it's the 4. And then because there can't be an ascending sequence, blue has to be the 3 and yellow the 1. So I think like 3, 1, 4 is a possibility that we would get from this telling me there's a 1. If instead this tells me blue is small, don't I end up with 1, 3, 5? Is what I think happened, right? Now, why was it again that I said this had to tell me there's a 4? Is there a proof of that? Or could it instead be telling me the sum is large? If I know there's a 1 and a 3 and the sum is large, and purple is the largest, if I know there's a 1 and a 3 and purple is largest, uniquely, then don't I already know the sum is more than 6? Yeah. No, because it could be 1, 3. Yeah. Because if the 3 is purple, then the sum isn't. Then there's too many 1s. Right? Or could I have a 1, 2, 3 somehow? Oh no. If 3 were purple, could I have 2, 1, 3? It seems like that would be possible, right? If C said there's a 1, this we know says there's a 3, this says purple is largest. Now, we know this doesn't say that the sum is 6. But we to prove the card is redundant, we need to prove that we already know, without using this card, that the sum is greater than 6, right? Which I don't think I can do. 213 would let this card be the one making up, fixing the ambiguity. If I ask D, would I get any useful information right now? No. Right? I didn't compose a question that would be good at asking D, I think, for some reason. It seems pretty stupid, because I thought asking D is a thing I was going to do. But I can't. Because I'm targeting both of these. I'll either get a yes or a no, and... Well, no. I'll definitely get a yes. Because it's either checking that there's a 4 or there's a big sum. Okay, so I guess I just have to call this round a bust. I can't find the answer now, and I thought I had a question that would help me here, but it doesn't. Blah. Okay, round 5, gross. Because I really don't think I can uniquely solve the puzzle. I need to know what C is telling me, and I might need to know what D is telling me? I don't think what D tells me can uniquely determine the solution, can it? Maybe so. I think I saw 2 different ways for... I should only need one question, I think. But I'm not sure what it has to be. So, if D told me there's a 4, and I knew there were a 3, which I do know, what would C be telling me? It could tell me blue is small, in which case it would have to be 1 or 2. Purple would have to be large, so it would be the 4. Because I'm assuming here it's telling me there's a 4, right? So blue would be small, yellow would be 3, purple would be 4. No, that's impossible. Hang on. If D tells me there's a 4, do I immediately reach a contradiction? No. It can't tell me that blue is small. It would have to tell me there's a 1. Because then I could let yellow be the 1. Whereas if it tells me blue is small, then yellow has to be a 3, which is a problem. So if I learn there's a 4, then I'd have to also learn there's a 1. I'd know the code is 341. Purple would have to be the 4. And then to disambiguate which one is the 1 and the 3, I would have to use this code, this verifier. So I think that makes sense. And if D tells me the sum is large, I already know there's a 3. If this told me blue were less than 3... Well, if this told me there were a 1... would that be a problem? I'd know there's a 3 and a 1. And I'd know purple is big. But I could just make it a 5. So if this is big, I can't be told there's a 1. I think this is the same thing I disproved earlier by checking there's a 1 and then checking what this tells me. But if this is big, could I be told blue is small? If blue is small and there's a 3, there has to be a number less than 3 and a 3. Purple has to be biggest. But aren't there still multiple possible answers here? Because purple could be 4 or it could be 5. And there's no way to distinguish, right? Yeah. So I don't think D can tell me that the sum is large. Because no matter what C tells me, I can't get a unique solution. Purple could be 4 or 5. It's not constrained enough. No, hang on. Couldn't it be... Well, right. If I learn that blue is small, then yellow has to be 3, and so purple has to be 5, not 4. But then blue can wiggle around between 2 and 1, and it doesn't bother anybody, doesn't it? No, it can't be 2. Because of this. So if I learn that this says there's a big sum, then one of these tells me that the code is 135. And the other one tells me something unclear. I'm left with ambiguity. A 1 and a 3, and either a 4 or a 5. Yeah, I have to ask one of these something. I can't help it. But I think once I've asked C, I'll know the answer. I hope. Or maybe if I ask D, which one do I want to ask? I think if I find out this, I'll know the answer, because one of them was possible and the other one was impossible. If I find out there's a 4? I don't know. I'm tired. Just, like, give me the damn answer. I might have to just ask both of them. I don't want to go through this logic anymore. So let's see. To ask C, I want to construct a number with no 1s, but blue is small, so 2. And I want a number with a large sum that has no 4s. Like that. Right? Yes. Okay. So let's just talk to C. I don't really remember if this is... I think it was like one of these... I'm going to ask D. I don't remember what's better. It says yes. Ah! Oh, that was a straight line? Really? It looked really curvy. Okay. D says yes. So that means D isn't looking for a 4. It's looking for a large sum. So I believe that narrows down what can be happening here, does it not? Or maybe not. Maybe both of these are possible and I'm just a dummy. I spent so long on hypotheticals that I wasn't taking notes on. So there's a large sum and a 3. If I'm told there's a 1 as well, then the 3 can't be... No. the 3 could be yellow. And purple could be like anything. Could be 5, right? I could have 1, 3, 5 or 3, 1, 5, I think. Yes. If I'm told there's a 1, I can't solve the puzzle. Because 3, 1, 5 and 1, 3, 5 are both indistinguishable. But if I'm told C is small, blue is small, I can solve the puzzle, right? It would have to be 1. And yellow would then have to be the 3, and purple would have to be 5 to avoid any sequences. So I'm not going to ask C. I'm going to punch in 1, 3, 5. I'm not doing any more double checking. I've gone insane already. 1, 3, 5. This is correct. Okay, thank God. Let's see how long the machine took. I'm not happy with my results. I took 5 rounds. No from ACE. And then also from AB. But a yes from D. No's from AB. Haven't gotten a lot of yeses yet, huh? No from B, yes from C. And then yes from D. Really? Yep, okay. I feel like I just needed to frame a better question. I somehow got confused and in round 4 didn't pose something that D could have answered meaningfully. Yeah, the machine beat me. 4 rounds and 12 questions, so I took 5 rounds and 12 questions. If I'd managed to include this question in the previous round, I would have had D solved, but I would have been asking a different question, so I might not have gotten as useful of answers from B and C, but probably good enough to solve. Okay, well, a tough puzzle. I gotta get out of here. I hate this game. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.